Hello guys, my name is Desmond and I welcome you to my lesson for today where we will be looking at mathematics. As you can see over there, trigonometric functions is what we will be looking at in today's lesson. So ladies and gentlemen, as always, please do allow me to say it is very much important that I say it is very, very much important because often what I'm about to say, it's massively, massive. Hey, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. Please, honorable member Nombuso, please do make sure that by the end of each and every lesson that I conduct, matter below, make sure that you learn something new. Very, very much important, ladies and gentlemen, over there. So, for the last time, can someone just indicate and confirm if you can? Is it everyone who can clearly see over there? And can you clearly hear me when I speak? Guys, can you clearly hear me and can you clearly see over there? No response. I'm not sure if you guys are able to clearly see and clearly hear me when I speak. Nombuso Makaula. Can you hear me, honorable member? And can you clearly see there? No. Something it's not okay. I'm not sure what could be the issue, but I can't hear you, honorable members. Maximum volume. Offense. Can you hear me, honorable member? Can you see there?
Yes, sir.
I think I heard a response, someone saying yes. Okay. Without any waste of time, this is what happens, Pantubakiti. Trigonometric functions is what we will be looking at in today's lesson. So I would encourage some of you guys to be writing some notes. Otherwise, if you want to only listen, you can still do that. And I will show you where you can find these notes that I've done specially for you. They are posted in our library. So let's quickly have a look at possible functions that you can sketch under trigonometry. Normally, you have a function which could be y, it's equals to sine angle. This is a function that you can sketch, or otherwise, it could be y, it's equals to cos of angle. Not only that, it could also be y, it's equals to tan angle. So this is a, let's say, phase 1 or stage 1 as far as trigonometric functions are concerned. That's where Matapelo, I used to say, let's have 3 stages. And the first stage, let's maybe call it a baby stage. And then the second stage, let's maybe call it a teenager stage. The last one, let's call it an adult stage. I think it makes it easier when explained in this manner. So, under baby stage, you just have y, which could be f of x is equals to sine x, g of x is equals to cos that, h of x is equals to tan that. But let's have a look at how functions at teenage stage look like. You can, for example, have y, which is equals to a sine angle. Y is equals to a cos angle. Notice the difference. A tan angle. I'm pretty much sure that you guys are able to notice the difference between a baby stage and teenage stage. I'm sure all of you guys can see that. It's exactly the same as that. I just added that letter A. So that means as we continue and as we go deeper, I will have to explain what is the impact of that A on your trigonometric function. Remember, guys, these are just the basics under trigonometric functions. Obviously, what I'm doing is just to take you through an introduction. I'm going to tell you everything that you need to know, everything that you need to be aware of, so that when we start answering exam type of question papers, you will have an idea of what to remember and what to apply. So let's maybe try to have a look at trigonometric functions at an adult stage. So obviously, easy, it starts to get more complicated. At this stage, obviously, you expect something complex. But I can tell you now, something gets difficult, complicated, or complex when you have got no clue, or when you are clueless, or when you've got no idea. But in this case, what I'm trying to do is to make sure that you guys have got an idea of what we are dealing with. So y is equals to a sine angle. Notice the difference. Y is equals to a cos angle plus q, or y is equals to a tan angle plus q. So I'm pretty much sure that you guys are able to notice that here I've just added that being q. So something very common is that it's either you sketch the sine, cos, or tan function. So that means we are actually talking about three types of functions. But what makes them to be complicated or difficult is this type of things, of which is a in this case. Here, you still have that a, and then you also have that q. So I'm about to now go deep into explaining what is what. So just make sure that you listen very carefully, and where you do not understand, make me aware. So someone, instead of writing, you can still take screenshots of these as your notes, but otherwise you are welcome not to write anything and listen, because everything that I'm writing there is posted in the library. I've prepared these notes and posted them in the library, so you can easily access them there. So let's see. The first thing that I want to talk about is what we call an amplitude. So that means under trigonometric functions, you should know about amplitude, of which amplitude we can give it a general formula. To say amplitude is actually half of the distance between maximum and minimum values. Offense, what do I mean by that? In a textbook, you might be given that as a formula, or in some textbooks, it might not even be available. But what I mean by that, obviously, when you sketch a function on a Cartesian plane having the y and the x axis, you might have, let's say, something similar to that. I'm just giving you guys an example, and they say that point there, maybe let's say it is 4, and then this point there, it is negative 4. So what is the maximum and the minimum of this function, the maximum and the minimum, it's actually the turning point of this function. So you can see the turning point is actually at where y is 4. So it's more like when we talk about the amplitude, we are referring to the y values. And the formula says half of the distance between maximum and the minimum. So it's more like you actually say the maximum value is that 4 there. And then you plus it with the minimum value, which is that. Remember, we are talking about the distance. That's why we don't consider the negative as far as distance is concerned. So that means you're going to say the maximum value being 4, you plus it with the minimum value being 4. What is the answer? This plus that, it's actually 8. So it's more like half of 8 is 4. So that means the amplitude of this trigonometric function is actually 4, and you calculate it using that formula. So for some reason, if here it was -6, you follow the same procedure. This plus that, it gives you what? 10. Half of 10 is 5, meaning the amplitude is 5. So I'm just giving you guys an idea of what is meant by the amplitude. Very, very much important, ladies and gentlemen, over there. Point number 2 that I want you guys to be aware of is that the graph of y is equals to a sine angle plus c, for example, or let me keep it simple and say plus q. And also the function of y is equals to a cos of angle. Angle could be x, could be any letter. Let me keep it simple and use theta there and say plus q. Both of these functions, they do have an amplitude. So that means you can calculate an amplitude for a function or a trigonometric function of sine and cos. But listen very carefully. The graph of y is equals to, let's say, a tan angle, let's say plus q. This one, it has no amplitude. Someone is wondering why these two have amplitude, but this one for tan does not have amplitude. The reason to that, Bantu Bagiti, is because for you to calculate the amplitude, what do you need? You need the maximum value and the minimum value. So that means the function for sine and cos, they have maximum and minimum value. But if this one for tan has no amplitude, it means it doesn't have the minimum and the maximum value. That is the simplest reason that you can give in case a question is being asked to say, why does that not have an amplitude? Remember, you might find that a function for sine, maybe let's say, for example, it does something similar to that. And then maybe another one for, let's say maybe this is for sine, and maybe for cos. I'm just giving an example, guys. Maybe for cos, it starts from the bottom and it does something similar to that. So for tan, this is how it looks like. I'm sure you guys still remember. You are going to have what we call the asymptotes there, and you will notice that maybe that function, it does that, and you have an arrow there which says up to infinity, and then maybe you have that up to infinity, and maybe you have that up to infinity. So can you hear what I'm saying? Up to infinity, meaning there is no maximum value, there is no minimum value. That is why it does not have amplitude. But this one, can you see? It has a maximum value and a minimum value. Maximum value and a minimum value. So with the max and minimum, that means you can calculate an amplitude. No maximum, no minimum. You cannot calculate an amplitude. I'm pretty much sure that it makes some sense. So I'm going to now move on to the next part of the notes. But before I go deeper, let me just quickly confirm if you guys are able to clearly hear me, and again, if you can still be able to see there. And most importantly, what I've explained up to this point, does it make sense? Bantu bakiti. Honorable members, are we still together? I'm losing confidence. I'm no longer sure if you guys are able to hear me, and also if you are able to see there. But I'm suspecting it could be that situation where the message is still on the way. But can you guys hear me when I speak? Kabelo Malete, can you hear me, honorable member?
Yes, sir.
Can I have someone to confirm? I just got a confirmation from Kabelo, but I need someone to also confirm if it's clear. Litlhogonolo, obedience.
Yes, sir.
Can you hear me? Okay,
Yes, sir.
100%. I will, with confidence, continue. So let's see. Remember to remain muted. Most importantly, this A, it normally refers to an amplitude. That A normally refers to an amplitude. So that means I've just explained all that you needed to be regarding that amplitude. So what's left is for me to discuss that Q value. And this is what I'm having on my notes. Positive Q value means upward shift. Obviously, know this from functions, which means negative Q will mean downwards a shift. So that means even the trigonometric functions, they do shift. And obviously, this Q value, it talks about the up and down shift. What is that single word? That includes the upward and the downward shift. That's what we call the vertical shift. So that means when we say a function shifts vertically, it means it shifts either upwards or downwards. Maybe, let's say, for example, you had something which was doing something similar to that, as an example, and now they say this has shifted downwards. Let's say maybe it was y is equals to, I'm just giving you guys an example, cos that, and then now we shifted, maybe let's say this one, it's actually y is equals to cos angle, and now they say it shifted downwards by -1. So that means from the origin, it shifts by -1, meaning this is how it will possibly look like. Yes, I think it will possibly look like that. Can you see? You took it exactly as it is. You just shifted it downwards by 1 unit. Otherwise, if it shifts upwards by 2 units, for example, that means possibly it will be doing something similar to that. I'm just giving you guys an example. Yes, something similar to that. That's if, for example, this one is y is equals to cos angle plus maybe let's say 2 there. Just for you to have an idea of what is meant by a function, not just a function, but a trigonometric function shifting up and down. Most importantly, it's the sine, cos, and tan functions which can shift vertically. Meaning all these functions, they do have the potential to shift up and down. It's not only the one for sine and cos, even for tan can shift up and down. I hope that part makes some sense. Most importantly, I'm now about to introduce what we call asymptotes. Good people, the graph of y is equals to a tan of angle. For example, maybe plus q or plus c or plus whatever. This function of tan, it is the only one that has what we call a asymptote. Asymptotes, asymptote. Only this one. It is the only one that has those equations of asymptotes. I'm pretty much sure that you guys still remember those, which is normally where when you punch an angle, you get an error. So for some of you who forgot what that is, let me quickly just say, for example, you might want to sketch the function of a tan angle, where maybe let's say this is negative 360, negative 270, negative what? I think it's 180 there. Is it going to be negative 90? 0, 90, 180, 270, 360. You will realize that maybe here on 270, you are having those broken lines. And then maybe here on 90 broken lines. Obviously, this side also 90 broken lines, 270 broken lines, and you will just be having your function doing something similar to that. And also for you to know whether it starts from there and then it goes up, or it starts from there, it goes down. You will also learn that as we continue in terms of what guides you, in terms of whether it goes up from there or it goes in that direction and then in that. So you will learn that as we continue. But for now, just remember that we have what we call asymptotes under the function of tan angle. Most importantly, I'm very much slow because I'm only giving you guys an introduction. I'm telling you, on our next lesson, it's going to be kusasoshuba bantu bakithi, if I may put it that way. But for now, today's lesson is a bit relaxed because we're just having a discussion on how we are going to attack these coming questions. Might not be today, but on our next lesson, that's when we might be looking at exam type of question papers. But for today, just an introduction. Most importantly, guys, you are advised to say at all the times, I think I was disconnected for a second. Okay, it seems like it's okay now. When you sketch this function of y, it's equals to a tan angle plus say include what we call the critical. What are those critical values? Good people, we talk about negative 315 degrees, negative degrees, negative 135 degrees. We also talk about negative 45 degrees. Then from here, let's go to a positive same value. So that means a positive 45 degrees, 135 degrees, 225 degrees, and lastly 315 degrees. What are these critical values? A very good question may be asked to say, speaker, what are these critical values? Remember, when you sketch, you're going to have your x-axis. These are the critical values. That 45 there obviously it's going to be 90 there. After 90, I think you add another 45, it takes you to there, and then from there another 45 is what is 180, I think, and then 180 plus 45, it takes you to there, and then from there 270, and then it takes you to there, and then up to 360. The same thing on this side. So these are what we call the critical values. That 45 there, 90, and then what else? Is it 135 there? These are what we call the critical values. So it's more like as you punch on this to try and plot, you might need to then punch whatever amplitude, tan 45, whatever, and then you get a point, then you make a dot for that point. You move on to 90, then you include this one also, so that you know whether from 90 you go to the positive side, or from that 90 you go to the negative side. That's how you're going to know whether from 90, or maybe from this, you are going to the positive upwards, or you're going to the negative side. It will make sense as we continue, but for now, as part of your notes, you can just include that to say, when you sketch the function for tan, include the critical values, and these are the critical values. Just always remember that. So I'm about to now give an example where we try to do a very quick sketch there. Anyone who's got a question or all that I've explained, does it make sense up to this point? And remember, guys, when I say does something make sense, it's not like I'm asking something outside what I've explained. I'm just saying all that I've explained. Did you get that? My question is limited to that. Don't for now think about something which could be tricky, or don't think about a question that was difficult and it feels like I've explained this and you are still wondering how you're going to solve that question based on what I've explained. Remember, always when I do my lessons, I always assume that you are completely blank, because everything that I'm going to be doing when I solve exam question papers, I'm going to do all of that based on what I've taught you. So that means I'm making an assumption that everyone doesn't know anything about trigonometric functions. Even if you know or you've mastered this chapter, I'm going to assume that you are completely blank, so that we all move in the same pace. So before I sketch, do you guys understand what I've explained up to this point? Especially those who started when the lesson started. Did everything make sense?
Yes, it was sense.
Yes.
Okay, 100%. So now I'm about to remove all of this, and I want to make you guys aware of something. You might not be aware that everything that I'll be doing, it's not at that baby stage, it's not at that teenage stage, but it is at an adult stage. What do I mean by that? When I have a y, it's equals to, let's say, sine of an angle. Anyone who can tell what is the a value and what is the q value? What is the a value? What is the q value? What is the amplitude and what is the q value? What is the value for the vertical shift? Anyone who would like to give it a try?
The A value is 1 and Q value is 0.
100%. The amplitude is equals to a invisible positive 1 there. And that Q value there, it is actually 0 because it is not there. Unlike if you had Y, let's say 2, maybe because of an angle minus 2. Can you see? This is the amplitude and this is your Q value, meaning your function of cos has shifted by 2 units downwards. So now let me quickly show you generally how you sketch. Let's say you are given f of x, which is equals to, let's say, sine of an angle. And it won't end there. They are going to say where angle is the element of negative 360 degrees and positive 360 degrees. So you've got two important information there, which is the function of f. Remember, f of x, it simply means y. So you have y is equals to sine x, or f of x is equals to sine x. And where the angle, can you see? They're saying where the angle, being that angle, is the element of that. So this is what we call an interval. What is an interval? They are saying, as you sketch that function of f, from the negative side of the angles, start from negative 360 and on positive 360, meaning let's say you are having 90 there, 180, 270. Here it must be 360. That means here negative 90, negative 180, negative 270, negative 360. That is what that interval means. Before you even get to that, this is what you look at, and you notice they are saying start from negative 360 degrees, negative 270 degrees, negative 180 degrees, negative 90 degrees, 90 degrees, what is it? 180 degrees, 270 degrees, 360 degrees. Then here you can maybe just have let's say 1, 2, negative 1, negative 2. Why am I just ending at 1 and 2? It's because I realize my amplitude is 1. So I am most likely to have my maximum value being 1. So let me not even have 1 there, but my 1, let me just put it there so that my function is going to be clear. Let's say this is 1, this is negative 1. So can you guys see we've done that Cartesian plane? Obviously, this is the origin based on that interval. If, for example, that interval, I'm giving an example, they say theta being the element of negative 270 degrees and 90 degrees. So that means your function, it was going to start from that angle being negative 270. So that means you're going to have negative 90 there, you're going to have negative 180 there, you're going to have negative 270. It ends there because that's what the interval says. On the positive side, it just ends at 90. So that means you're only going to have 90 there. So that means your function, it will just either start here and does whatever that it does, but it's going to end there at 90. That's what that interval means. But in this case, they're saying from negative 360 to positive 360. So that is why I drew those angles from there up to there. And most importantly, trigonometric functions, Bantu Bagiti, it's not different from what you know on a Cartesian plane. You know, this is angle 0 degrees, this is 90 degrees, this is 180 degrees, this is 230 degrees, this is 360 degrees, in a form of a circle. But what they do is just to take this circle and actually put it in a form of a straight line. And then on the negative side, it's more like it's from that 0 and its angle in that clockwise direction. And then it starts from that 0 and then it's to the negative side. So don't get confused in terms of you seeing angles being on a horizontal line. It's just that circle now placed as a straight line so that we can easily sketch. So let's quickly try to sketch. This is how I usually sketch. I always start from left going towards the right. So that means I'm going to punch sine. Vuga malamba, vuga malamba, vuga malamba. Yes. Always sleepy in that one. Let's see. Okay. Sine, what is the angle? Negative 360. Can you see it gives you 0? Then you put a dot where it's 0. Then you go and edit that angle. Let's say it's now negative 270. What are you get? You get 1, which is positive 1. So that's why I'm going to put a 1 there. Let's go back. Edit that part. We go to 90, then you put 90 there. It gives you negative 1, which is there. Under 90 on negative 1. Let's go to 0. At 0, it's 0. You put a dot at 0. Let's go to 90. At 90, it gives positive 1 there. Let me remove that because it's not part of the question, just to remove those to get some space. So let's see. We now go to 180. You go edit, then you go to 80. At 180, it's 0 there. It goes to 270. At 270, it gives you negative 1. I'm telling you guys, it might be a very boring exercise, but this is where it starts. I know there are some learners who don't understand how things work. They think because they are having challenges in grade 12, this is not beneficial, or it's just too easy. And they tend to ignore this type of information. But I'm telling you, when we do those complicated questions, I will be referring from time to time to what we are doing now. So if you ignore this type of lessons and it feels like it's too simple, when we do complicated questions, you might not understand where the complexity comes from. So let's see. Now it's just a matter of joining the dots. You connect the dots. You just connect the dots. Can you see? You just connect the dots. Then lastly, you say, this is the function of f. Anyone who's got a question, or does it make sense what I've done over there? Bantu Bagiti.
Thanks.
But does it make sense to everyone? I think it does. I think it does. Lastly, let's do this type. Let's do this one. G of x is equals to tan of angle. And then let's give our interval to be what can we say? Let's say negative 180 degrees and 180 degrees. Yes, I think this one is going to be an interesting one because it's in most cases where learners get confused by this type of a function of a tan. Here comes a question. Based on the notes that you've written, what did I say you must always include when you sketch a function of tan angle? What did I say? You must always include. Remember, guys, in case if you've got no idea, please do say no idea so that I'm aware that you got the question, but you just don't have an idea or you forgot. If you keep quiet, I'll just be waiting, thinking you are still thinking. Do you still remember what I said? Silence in court. I'm not sure if you guys got my question. Remember, guys, in case if you forgot or you've got no idea, please say so that I'm aware and I will explain. What is it that I said when sketching a function of a tan angle? You must always remember or always include when sketching tan function. Okay, maybe let me answer myself. If you remember, I said when sketching a tan function, always remember critical values. Do you guys remember now? So the critical values, obviously, I've given you those values. Here we are having negative 45 degrees. Here we are having whatever value. Here, whatever value. Here, whatever value. Maybe let me do something so that you guys understand why those critical values are necessary and where they come to play. Let's see. What do you guys get when you punch? I said let's start from left to right. What do you get when you punch a ton of 180? What are you guys getting there?
Room.
0. Okay, 100%. You're getting 0. Let's say we did not include those critical values. Let's move on to negative 90 now. What are you getting when you punch a... Okay, Matapelo, I made a mistake. I had to say negative 180. What are you getting for negative 180? Let's see if it's 0. Yes, it's still 0. Okay, let's go to a negative 90. What are you getting as negative 90?
5.
Hmm?
5.
Oh, undefined. Okay, error. So that error, it means this is where you are having your asymptote, meaning your line won't cross or touch that. So now let's move on to 0. What are you getting for 0? I'm getting 0. Let's go to positive 90. What are you getting for positive 90? I'm getting error. That's why I'm doing that broken line, because I'm getting error. Let's go to 180. Obviously, we knew 180, we saw it gives us a 0 there. So, Bongiwe Ivy, them are IVs. The reason why you need these critical values is because if you don't have them, you don't know where to go from that 0. Do you go like that or do you go like that? Here, where do you go? Do you go in that direction or do you go in that direction? Actually there, because this is a point that we know it's 0, but we have to sketch. Do we therefore go in that direction or that direction? Do we go in that direction or do we go in... So do you guys notice the importance of critical values? Let's maybe continue. Obviously, here it's negative 45 degrees. Here it's what? A negative, is it 135? I think it's negative 135. And then here, obviously positive 45. What about here? Positive 135 degrees. Let's punch again, Matabelo. So let's hello, I come back. I'm not sure what happened there, but let's continue. What are you guys getting when you punch tan negative 135? What are you getting?
1.
100%. So this is where you make a dot. Above that, along that. What about negative 45? What are you getting? Negative 1, it's what I'm also getting. What about now, positive 45? What are you getting? I'm getting 1. I'm not sure if you guys are calculating. Let's go to 135. What are you guys getting for 135?
1.
Positive. Eh?
1.
Guys, what are you getting for tan 35? Is it 1?
Is negative 1.
Yes, negative 1. So you're going to put a negative 1, a point there. So can you now see, Matapelo, that from that point you now know where to go? That means you go in that direction. And then you can see, you just connect the dot. From there, you know you go in that direction. And remember, your line must never touch this. If it touches that, odoile. You also do the same. You connect the dots, and then your line does that. If it touch or cross that, odoile. From there, you know where it goes. If it touch that, odoile. So that's how you finish it off, and you can just say g there. Then we know this is the function of g of x. Does it make sense to everyone in terms of how you sketch the tan function?
The question.
You have a question, Matapel? Or you saying you understand?
I have a question.
Oh, yes. What is the question?
If we draw sine theta, we use f at x, or we can use g at x.
So remember, it depends on what examiner gave you. So for this one, they said this is the function of Franco. That means after you sketch it, you're going to use a f to say that was the function of Franco. But this one is for Bra George. That is why after you sketch it, you need to say this is the one for Bra George. Does it make sense, Matapelo? But wait, offense kabelo bongiwe lwandiswa letlhogonolo nombuso bosisiwe. Guys, are we still together?
Yes, sir.
Yeah.
Okay, so very quickly, let me give you this for you to use as practice. Y is equals to, let's say, 4 cos x. Also, y is equals to negative 3 sine x. Remember, that x is now the angle. And then maybe let me give you this one of y. It's equals to, let's say, 1 minus 2 cos x. Maybe let me not confuse you with that x and maybe say theta, theta, theta. And the last one, maybe let me give you this one, which says 2 tan angle. You can just take a screenshot, and then for all of this, that's where that angle is the element of 0 degrees and 360 degrees. I'm going to remove all of that. Did you guys take screenshots, and do you understand what is expected of you there? You just do it as practice and see if you can be able to sketch those following exactly the procedure that we have done, where you start by drawing that and then you start punching those angles. Whatever value that you get, you put a dot there, and then after you just connect the dots. You draw them on separate axes. So that means you'll draw this one on its axis, this one on its axis, this one and that one on their own axis. Does it make sense to everyone? Guys, does it make sense? What is expected of you?
Yes, sir.
Yes, sir.
Okay,
Yes,
100%. So I'm
does.
just going to remove all of that, and then from there, let's continue. So, something very much important. I'm pretty much sure that let me try to bring the screen. It was load shedding on my side. That's why I'm having this challenge. So let's see. Let's say we are having negative that, and then let's say we are having negative 270 there, and then let's say negative 180 there, and then we have negative 90 there, 90 there, 180 there, 270 there, and then 360 there, whatever there. So let's see. Let's say you have this function doing m, and then now you still have another m. You still have another m. So when we talk about the period, we talk about the interval over which the graph repeats its shape. So can you see the shape of m is completed over a period of from there to there is 90 plus another 90 takes you there. So that means the period for this function is 160. Why? Because it does a complete shape of m over a period of 180. You can see from there to there, it does another m. So from a negative 180, if you add 90, takes you there. If you add 90, takes you to there. Actually, it shouldn't be there, but that m, it actually had to end there. And then the new one starts from there, it does that, and then this one, it does that. Yes. So that means from there to there, it's another period of 180 degrees, and then another m 180 degrees there, and then another m over a period of 100. So that means the function or the period, it's actually 180, because after every 180, it repeats that same shape. I'm not sure if it makes sense, guys. Maybe something, let's say this side it was negative 360 degrees, and then here positive 360 degrees. You have that negative 270, negative 180, 90, 90, 180, 270, that. Let's say you have a function that does that, that, and then that. It ends there. And again, it does that, that, and then it ends there. So can you see, it starts from there, and then it goes up, down, and then it ends there. You can see that this same shape, it's repeated from there. Just like there, it starts from that 0, it does that, it goes down, it goes up, it goes down, it goes up to there. So that means the period for this one, it's actually 360 degrees. Because after every 360 degrees, you can see from 0 to 360 degrees there, it has a complete shape. So that is what is meant by the period of a function. Does it make sense, guys?
Yes.
But does it make sense to everyone before I move on to the next part?
Yes, sir.
100%. So I just wanted you guys to have an idea of what. Yes. Is it a question coming through?
Yes, sir. So I wanted to ask you, from like the graph you just drew, I get it. You said, Hore, the shape repeats itself twice. Why is it like not 4 times? Because yeah, it's
Okay.
what you did see the shape of the graph.
Okay. No, I understand, honorable member. How am I going to explain this? It doesn't mean it repeats. It always repeat itself 4 times, 3 times, 2 times, or whatever. It's a matter of over which period do we see the same shape again. Let's say maybe we have 1, 2, 3, -1, -2, -3. Then this is what I'm going to do. There is a shape, another shape again of the same shape. Same shape again, same shape again, same shape again, same shape again. Just as an example, so the question would be, what is the period of that? It's more like we're saying over which period do we see a repetition of the same shape. So can you see from there to there, we see that shape and it repeats again. It repeats again, it repeats again, repeats again, repeats again. So it's more like over a period of 1 or at an interval of 1, we see that shape repeating itself. So that means the period for that shape is actually 1. I'm not sure if it now makes sense, honorable member. So it's more like after what, how, hey, ngizoyisho kanjani le nto leyo? But does it make sense, honorable member?
Yes, sir. But sir, I was referring to like the question you just did.
Maybe let me try to redraw that same one. I think, yes, but now you see, I forgot what I drew. I forgot what I drew. Maybe let me draw something. Then we'll start talking from there, because let's see. Let's say we are having 90 there. It's going to be 180, 270, 360. Yes. -90, -180, -270, -360. Then let me do what? I'm not sure if it's this one that I drew. And then now,
Yes, sir.
okay. And then what was your question there, honorable member?
So my question is like the period. You said the period was 2, and you said like the shape of the graph was repeating itself twice, but I saw 4 times. So how is it like? Will you please explain why is it 2 times instead of like being 4 times?
Now I'll need to remember what I said, but a very good question there. So remember, the period is an angle, not 2 as a number. So let's see. It's more like over which period do we see the function repeating itself? Let me quickly do this. I think I'm getting your point, honorable member. And then we have that there. And then let's maybe do the same. Yeah, I think now I'm getting your point, honorable member. I think now I'm getting your point. I think what I said was you have that function starting from there, doing that up to there. And then I said it does that again up to there. Yeah, a very good question there, honorable member. I think with me having to explain this, you will then understand as we continue. But remember, what the honorable member is seeing when she says 4, she sees this shape starting from there being 1, 2, 3, and then this is its own period, and then it does the same thing, that and that, and then can you see it does the same thing, and then from there it does that up to there. Yeah, now I understand you on, and then it does that up to there, and then can you see, and then it repeats itself how many times? 1, 2, 3, 4 times. That's what honorable member is saying. But now, in terms of the period you don't say it's either it's 1, 2, 3, or 4, but the period is in a form of angle. You just say from there to there. What is the period? From there to there, the distance is what is it? It's 180. Yes, 180 degrees. 180. So that means it repeats itself after every 180 degrees. Whereas in my case, I said it repeats itself after every 360 degrees. So at this stage, honorable member, exactly what you are thinking, it's not like you are wrong. You are correct. The only difference is that I did not give the formula of that function, because the formula, as an example, it could be y is equals to, let's say, cos angle. But remember, as we continue with our lesson for today, you will realize that the formula could be y is equals to cos. Then in between, you have an angle or whatever value. Let me say a value, which could be to that. Or you could have y, let's say cos 1 over 2 that. Of which this has a potential to influence the period, which is what I'm going to also explain as we continue. But for now, whatever that you are saying, it's not like you are wrong. You can say it repeats itself after every 180, or it repeats itself 4 times. Also on my side, just to generalize my explanation, I just said it repeat that shape 2 times, because I started it from there, and then it does that up to there, and then that up to there. Let's now forget about all of those, just to keep it simple and clear to everyone. You say, whether you say it repeats itself 2 times, or 4 times, or you can say 1 time. If you say 1 time, meaning from there all the way up to there, that means your period is going to be 360 plus 360, which is whatever the value that you get when you plus those two. But it's not really about the accuracy of that I just want you guys to notice what is meant by the period. I'm not sure, Kabelo, if you understand that general explanation based on what is meant by the period. I wanted honorable members of the opposition party to understand that the period simply refers to the interval over which the graph repeats itself. That's what I actually wanted to explain on that one. So that means if we say it repeats itself 4 times, that means in your case, the period is 180. If I say how many times? 2 times, that means my period is 360. But with us having to be accurate, we will need to know what is the equation for that function. Then that's when we're going to be able to calculate the exact value of the period. Does it make sense there, Kabelo, and everyone else?
Yes, sir.
Okay, 100%. So, as part of your notes, I want you guys to note down something very much important here, to say these graphs, the one for y, it's equals to let's just say a sine of an angle plus q. Also the one for y, it's equals to, let's say, a cos angle plus q. I want you guys to be aware that both of these actually have a period which is equals to 360 degrees. But for this one of tan, because this one is actually special, that's why this one, it has a period of 180 degrees. Yes, 180 degrees. So let's say generally the function of sine and cos, they have a period of that. This one for tan, it has a period of 180 degrees. I'm going to go deeper and explain how you can still find different types of or different periods for different functions. But for now, do you generally understand what is meant by generally for those two 360, for that 180? Does it make sense to everyone before I continue? Was that a yes?
Yes, sir.
Hear you.
Sir, your mic is muted.
I can hear you.
So you're on mute.
Yes, sis. Yes, sis. Hey, I was busy praying, guys. Busy praying in tongues, not realizing that my mic is on mute. Let me, is it going to be a re-prayer? But whatever that it is, I was saying we do have a formula for calculating the period. These two, they have a period of 360, and that is why they have a formula which says P is equals to 360 degrees divided by B. For this one of 180, it's going to be P is equals to 180 degrees divided by B. Someone is wondering, where is that B coming from now? So this is where the B is coming from. Remember, we discussed this type of functions from a baby stage to teenage stage to adult stage. I'm not sure what is the stage after adult stage. Maybe let's call it the granny or the grandpa stage. So this is that stage. Y it's equals to A. Let's maybe start with this one of sine. Then this is where the B comes in. And then maybe plus Q there. And then this is the other one. A cos B angle plus that. And then we still have that one. A tan then B angle plus Q. And then we said to calculate the period for this one, it's equals to 360 degrees divided by B. And then for this one, period is equals to 180 degrees divided by B. I'm telling you guys, I can promise you now, the way in which this lesson is being presented, it won't be presented to you in the same manner at school. It might be completely different. And with you attending this lesson, you will understand everything much better when explained in whichever way. Because with you not knowing all of this, you will always get lost under trigonometry, especially when it comes to functions, because you need this basic understanding. And without this basic understanding, I'm telling you, you will always feel lost, because I'll be talking about something of which you don't know. How do I know that I must do whatever that I'll be doing? But let's now try to be practical. So you will notice that in some instances, let's say number one, you might be given y, which is equals to 2, let's say 3 angle. And then number two, you might be given, let's say y, it's equals to, let's say -3, and maybe let's say cos a half angle. And then maybe for this one, let's say you are given y, which is equals to negative tan, let's say 2/5 angle, being number 3. Can you guys tell me what is the period for number 1? What is the period for function number 2? What is the period for function number 3? I want to check if you guys will manage to do this one. If you do, it's a very well done and a good indication that you understand. What is the period for function number 1, number 2, and number 3? Don't wait for someone to say something. Just say whatever that you get or whatever that you think it is.
120.
120 for which one?
For the first one, sir.
120. That one.
Yes,
and
sir.
then for the second one,
$720.
for the third one,
$450.
450 degrees. So You are correct, honorable members. You just say, based on what you are given, that B value, it is the one that helps you to calculate the period. That B value. Maybe let me do that last one. Hey, I don't trust you guys. You. 5 over, no. Hey, I don't trust myself now. Oh, yes, I withdraw. You are correct on that one. So, who was it? Kabza the Makabelo. Let's try to now discuss something. So, can you see that when I drew that thing and say it repeats itself, whatever, can you see, honorable member, that I was few steps ahead because I knew it's not always where it can repeat itself after that interval. Does it now make sense, Kabza? It is because of that B value.
Yes,
this
sir.
B value, it has an influence on the period of a function. But also, I'm not saying you were wrong in thinking that it repeats itself after that. You were absolutely correct. The only difference was that I did not make it clear regarding what was the equation of that. But what you said, at least it made me to expand on my explanation on that. So now everyone understands that it doesn't mean the period is fixed. Period is never fixed, but is dependent on that B value. So in most cases, if you find a teacher who does not fully understand this type of functions, they are going to tell you that if you are given a function similar to this one, they are going to say the period for this is equals to 360 degrees. Also for this one, the period is equals to 360 degrees. And then they say for this one, it's equals to 180 degrees. And it ends there. And I'm telling you, Ufense, in exam, you are therefore going to have, let's say, negative tan 1 over 2 angle. And they say, what is the period for this one? And you're going to say the period is 180. And you get it wrong. And you wonder, why or how am I getting wrong? Because they said for tan is that. They are correct. For tan, it is that. For this, it is that. For that, it is that. But for this, it is not that. And you find that they did not explain how this period works. So can someone explain, how do we know that for this one is 360, for this one is 360, for this one is tan? How do we know?
The value of B is 1.
100%. 100%. The value of B is an invisible one. It is there, but you won't see it. The value of the amplitude is invisible one there. Pantubaki T. So that means when you calculate the period, you're going to say P is equals to, for this 2 is going to be 360 degrees divided by 1, which is just that 360. For this one, you're going to say 180 degrees divided by 1. That's why it is that. Can you see? They are correct in telling you that the period for those is that. But if you don't know that there is a formula which says P is equals to whatever the period, which is the general period divided by B, you will never get it correct. Does it make sense to everyone? These are some of the most important tips that you might not easily get. But does it make sense to everyone?
Yes, sir.
Yes.
100%. So I'm now going to remove all of this. We are now approaching the last part of our lesson for today, and I would like for you guys to listen very carefully. This is what I'm teaching you guys, the rules for sketching trigonometric functions. The rules for sketching. If you can understand this, I'm telling you now, you will never go wrong. Never. Remember, we are talking about this function of y, let's say it's equals to sine b x, or otherwise it could be y equals to cos bx, or y it's equals to tan bx. I'm just interested on that b value there. That is why I'm not including the a and also that shift. The a, that shift, you just know is there, but the a is 1, the shift, vertical shift is 0. But you will realize why I'm saying I'm interested on that b. These are the rules. Number 1, you find period. Do you guys know how to find the period of a graph? Yes or no?
No.
So is it what you just explained? Like,
yes.
Is it like gonna be for 10, 180 over?
Yes. Yes. Exactly that. Bongiwe, I'm not sure if you missed that part because I noticed you were doing in and out. But do you remember that part where I was saying to calculate the period for the function of sine and cos? It's p is equals to 360 divided by b. Do you still remember that part?
I'm sorry, I remember.
Yes. So exactly that. That's how you find the period of a function. Let me keep it simple and say this is step number 1. And then step number 2, you find what we call critical points. Find critical points. You guys will be surprised if I tell you that what I'm teaching you now, I did not know all of this when I was in high school, but I just knew how to work around this. But what I'm teaching you guys is the most simplest way of doing this. It's more like I'm giving you guys information on a silver platter, as they say. But I think this one is coming from a gold platter, Bantu Bagiti. Because now you know how to determine or find the period of a function using this formula. P equals to 360 degrees divided by B. And then again, you know where to use this one of P is equals to 180 degrees divided by B. Anyone who can tell or guess, how do we find the critical values? I'm suspecting no one knows except those who have been attending my lessons since the previous years. Anyone who knows how do we find the critical points? How do we calculate the critical points for a function, whether it is that of sine, cos, or tan? How do we calculate the critical points? In case you don't know, please do make sure to mention and say no idea or you do not know. Hmm?
I don't know,
I
sir.
don't know.
Okay, so I'm not surprised, but it's very, very easy. You won't believe it if I tell you that to find the critical points, you just take the period that you calculated, you just divide it by 4. I agree. You guys remember that from your y and your x-axis, how many quadrants are you having? Obviously 0, let's say 0, 90, 180, 270, 360 degrees. Can you see? You have quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. That's how you will remember that you just take your period and divide it by 4 for 4 quadrants. Or otherwise, one would say, from the origin, you have those main angles being 90, 180, 270, then 360. It's 1, 2, 3, 4. So you divide it by 4. Does it make sense how you find the critical points? Let's do an example. That's when it's going to make a perfect sense. Let's say you have a function being y, it's equals to sine of an angle. Bongiwe, I'm telling you, someone who does not know all of this information, straight away, you will see them already sketching all of this. They're having x and y there. And somewhere they're just saying 90 there. You don't know where that 90 is coming from or who told them to do 90. But because they've been seeing their teacher doing this, that's what they just do. That's what they just do. And when they try to plot, sometimes you might punch 90 there, but you're getting something of which you won't even know how to connect the dots. So it's more like these rules are making it easier for us to connect the dots. Let's follow the rules to plot that function. Let's start with the first step. What is the period for that function? Hmm?
360.
100%. The period is 360 degrees. And then, what are the critical points for this function?
It's negative 360, negative 270, negative 180, negative 90, and then 90, 180, 270, and 360.
The honorable member is correct, but I just wanted maybe, let me say the critical points or the interval. Yes, let me say the interval. Which are the critical points, or how do we calculate the critical points?
.360 after that we divide by 4, it gives us
100%.
90.
It gives us 90. So that means the interval is 90. That is why honorable member is saying from negative 360, you need to have a point at an interval of 90. So it's more like from 0. Because the interval is 90, that means you do in multiples of 90. From here, 90, you add another 90 there, another 90 there, another 90 there. That's how you get the interval. So maybe let's update our notes. I'm glad honorable member said negative 360, negative 270, whatever, because those are the critical points. But actually, this formula, it helps us to calculate or to find the interval. Yes, add it to your notes to say, this is the formula that we use to calculate the interval. You take your period, you divide it by 4. So let's try to do this. If you are given y, it's equals to, let's say, cos of 2 angle. So for this one, I'm no longer going to say how do we calculate the period, but I'm going to say what is the interval for this one. Anyone who can tell if they say sketch this?
45, sir.
What will be the interval? She's saying 45. Do you all agree? Guys, do you agree the interval is 45? Silence in court. Lwandiswa, do you understand where they got that 45?
Sir, I understand.
Okay, 100%. So this 45 IV, it is the one that guides you the interval at which you should show on your whatever. Let's say, for example, they said sketch this, whereby that angle is the element of, let's say, 0 degrees and let's say 270 degrees. So that means it is actually going to start this side where you are having 0. The next point that you must show is 45 degrees. These are the critical points. The next one you just add by 45. What is it? It's going to be 90. The next one, it's going to be what? What is it going to be? It's going to be, is it that 135? I think it's that 135. The next one is going to be 180. I think I'm going to run out of space. Let's say the next one is 180 there. What will the next one be before we get to the last one? Is it 2? Hey, what is that? Let's see. 225. 180 plus 45. 450. Yes, is 225. And then the last one is 270. 100%. So can you see? You have followed those rules. But if you did not follow the rules, someone was going to move from they were going to do it this way of saying 90, that, and then that. Let's see what is going to happen if you just do that and don't follow the rules. So let's try to sketch maybe doing it the correct way. So IV, that means you're going to say cos 2, let's see, cos, then you say 2, you open brackets, you start with 0, you close. What does it give you? What are you guys getting there? Hmm? Okay, me, I'm getting 0. I'm now going to move on to the next point, which is this one for 45. For 45, I'm getting 0. What are you guys getting? Hmm?
As we say cos 45, it gives us square root of 2 divided by 2.
Hmm? Okay, I got a different answer. Someone else, what are you getting? Sure, I'm not sure if honorable member left or if we're still together. Matapelo, what did you punch there, honorable member?
Cos 45, ring, close brackets, and palm, square root of 2 divided by 2.
Oh, okay. So a mistake that you did was to not include that 2. Can you see? I think so. Let me check. Yes. Can you see, Matapelo? So you need to punch cos 2 and then you open bracket. So you punch it like this. You say cos, it's going to open, you say 2, you open, then you do 45, you close, and then you close for this one. Then you get an answer. Then all that you do is to go back and edit that one. Does it make sense? So I got 0 when I punched that. What are you guys getting? Let me move on to the next one.
Also,
I'm going to 90 now. 290, I'm getting -1. Then I'm going to put a plot there on -1. I'm going to move on to the next one, being 135. I'm getting 0 there. I'm going to the next one, which is 180. I'm getting +1, which is there. Now I'm going to the next one, which is 225. I'm getting 0 there. I'm going to that last one. I'm already seeing the pattern now. It might be -1. Let's see, 270. I'm getting -1. Yes. So can you see? You can now connect the dots. So let's see. That means you start from there and then you do that. And then from there it goes there. And then from there it goes there. And then from there it goes there. And from there it goes there. And from it goes there. Then it is done. This is that function. So let's see, if you only had 90, 180 and that means you're only going to have that point, which is -1 there. And then from there, you're going to have that point of 180, which is going to give you 1. And then there you have this point, which is going to give you -1. So I'm not sure if you guys are able to notice that let's say there, obviously at 0 it gives you that. So without these critical values, it might be a bit tricky because you won't know whether the function does that. Or if it does that. Or if it does whatever. So that is why I'm saying the correct procedure is for you to find the interval and then use that interval so that at every point you know whether it's 1 or you know whether it's 0, 1, 0, 1, 0, 2 or whatever. Because if you are having 2 there, you still follow the same procedure and you just punch 2 cos of that and then 2 and then whatever angle. It's going to give you a point. Then, for example, if you just put 2 there, is 2 there, you just put a 2 there. And then from there, you might find that it takes you back to there, but to -2 now. And then to there again, but to +2. And then there again, but to -2. Something of that nature, because 2 is the amplitude, where it gives you the maximum and also the minimum value. Do you guys have a better understanding now of how the trigonometric functions work in terms of how you sketch? Does it make sense, guys?
Yes, sir.
Yeah.
Okay, 100%. So very quickly, I'm going to remove all of this and give you guys the code for today. But I'm going to give it in a smart
Definitely,
way.
sir.
100%. This is going to be your code for today. I'm giving you this one, cos 3 angle. And then a code for today, you are either going to just say amplitude. This is you commenting amplitude, and then you say it's equals to, then you give an answer for the amplitude of that. Or you will say what is it? The period, it's equals to whatever that it is for that. And then the other one can just say the interval, it's equals to whatever that it is. Maybe let me make it even more interesting and say someone can say vertical shift, it's equals to whatever. But most importantly, this is not the end of our lesson. I'm just going to quickly explain something very quickly. This is going to be your code. But most importantly, if you guys remember, I explained what is meant by the vertical shift. I need to complete this because on our, what is it? On our next lesson, which is next week, Saturday, we are now going to start solving for exam type of question paper. So that is why I need to complete all of this so that we start solving exam questions and not doing an introduction. So for those of you guys who are attending my lesson for the very first time today, you are lucky because we are actually starting a new part under trigonometry. So whatever that I've explained today, make sure that you catch it up during the week so that you will follow on our next lesson. And also, that's if you will be on a package which accommodates you for extra weekend classes. Just in case, for example, there are those who are only doing what is it? They're only doing, let's say, one subject. If you're only doing one subject and you can't, for example, go for that gold package, especially those who are writing May, June, just send an inbox to indicate you're only doing maths because you'll be writing in May and you would like to also attend the extra weekend classes. Then we'll see how we can rearrange that package, especially for you in that case. So let's see the last part. If you remember, we spoke about the vertical shift to say whether you have tan angle, cos angle, or sine angle. For as long as you have plus Q, it refers to the vertical shift. So I want you guys to be aware of the horizontal shift because it is also available under this type of functions. You can have a function being y, it's equals to, let's say, sine, and then you are having x plus p. I'm sure you are not seeing this for the first time. Maybe having y, it's equals to, let's say, cos angle a plus p, or otherwise this one for tan, being a tan angle plus p. I'm going to tell you guys something that you should at all times remember. If you are having a function, or let's say for a function, let's say maybe is g of x, and they say maybe a sine into, let's say, angle, and then they say plus 30 degrees. This thing, it means this function shifted to the left. What makes it to shift to the left? It is because of that sign of positive. By how many units, or by how many period, or by how many value? Yes, let me say by how many units did it shift to the left? It shifted by 30 degrees, by that angle. So that means for, let's say, f of x, which could be, let's say, cos of maybe angle, and then let's say negative 60 there. So that means this one, it shifted in the opposite direction, being right. What makes it to shift to the right? It is because of that negative value. By how many units did it shift? By 60 degrees to the right. I'm not sure if what I've explained makes sense to everyone. Guys, do you understand what I've just explained there?
Yes, sir.
Let me quickly make a practical example so that you guys will never forget this. Let's say, for example, you are having a function, let's say y is equals to a cos into x plus, let's say, 45 degrees. Actually, this thing is the same as a function of y is equals to cos of angle. And then this same function, you just shift it by 45 degrees. But now, in which direction? Is it to the left or to the right? This is going to tell you. Then it means it shifted to the left. So if when you sketch y is equals to cos x, let's say maybe it does that. If it does that, and let's say here, maybe let's say this is 45, and then there it is 90. There you are having whatever. Is it 135? And then here you're having 180. So that means if when you sketch this type of a function, it looks like that. For you to end up sketching that, you just shift it by 45 in which direction? To the left. So that means it is now going to start here on negative 45 degrees, and then let's see, what does it do? I think it is therefore going to do something. What is it? Because you just take this shape as it is, you just shift it to the left, then it is just going to be doing something similar to that. I think I'm doing it correctly there. Yes. This same thing, you just take it and shift it to the left. If it had a negative value there, that means it is that same shape. You just shift it by 45 to the right, meaning it was going to do something similar to that, and then it ends there. What was that? I think that one is 225 because you just shifted it by 45. I'm not sure if I confused you guys, but do you sort of have an idea of what I'm trying to explain, guys, with what I've just done there? In terms of the sideways shift, does it make sense? This one shifted left by 45, and then this one shifted right by 45. If you shift it by a 90, that means it is actually from that point, it is going to start from there and does that.
Yes, sir.
So, guys, this brings us to the end of our lesson for today. I'm not sure if you guys have got any questions before I sign out. I'm hoping you guys found today's lesson valuable. But most importantly, did you guys understand what I've explained in today's lesson? And are there any questions in relation to today's lesson? Or you will have some more questions as we solve for exam type of question papers? Okay, I'm assuming All was
Sorry
clear
if I
in
may
today's.
ask. Remember you
Yeah.
gave us like the roots, sir?
Yes.
Yeah. As I was saying, remember you gave us the rules for sketching the graphs like of trigonometry functions. So sir,
yes, trig functions.
you gave us, remember you gave us y is equal to sin bx, y is equals to cos bx, y is equal to tan bx. So sir, you only gave us like, yes sir, about, you gave us about 2 steps. Is it like, is that all?
Yes, yes, honorable member. That's all. So that means where you are given an equation, you need to know where is your b value. As part of your homework, I'll just give it to you in a simplest form. Try to find out where the b value is with this type of a function. Is it cos of bx plus an angle, which could be 45, which could be 30 or whatever. Maybe let me say plus or minus angle. So it's more like I'm saying whatever the trig ratio here could be. Let's say it could be sine, it could be cos, it could be tan. Yes. What I'm saying is try to investigate if indeed the b value for a function given in this format, it is there. And also try to plot this type of a function where you follow those rules and check if it's going to allow you to plot nicely without a hassle. Remember, Kabilo, the reason why we follow those rules is so that you are able to connect the dots. That is the main important part of sketching a trig function. It's for you to be able to connect the dots. If you don't follow the rules, you can still manage to plot it, but it might be after a long walk to freedom. But just to make sure that you quickly work it out, follow the rules. Are you answered, honorable member of the opposition party? Kabza, I'm not sure if the message is still delivering. Let's see who's on the line. Sibusiso Maham, I'm about to sign out, honorable member. Are we then going to discuss the rest next weekend, or is there someone who's got a question before I sign out? Five, 4, 3, 2, 1. Ladies and gentlemen, thanks very much for joining. My name is Desmond. You guys have a very good night. But wait, before you guys leave, make sure that you attend an online event on Monday. Exact time to be confirmed. So that means on Monday, there is no lesson. If you want to know what we will be talking about or what the event is all about, go to homepage and then you'll see a list of where you wrote tests, recorded lessons. There's somewhere you will see, I think it's above library, you will see career exhibition. Click there and you will see what we discussed on our first event and what we are going to discuss on our second event. If you are a parent, just make sure to also participate if you can, so that you can be able to assist your child to ask questions that they might be having. And also as a parent, you will be given an opportunity to ask questions. So we discuss everything related to high school learners, just to plan way forward after matriculation, just to discuss the challenges that you guys will be facing, just to discuss online applications, bursaries, challenges that you might also face as a first year student. So there are a lot of things that will be discussed on our online event. So just make sure not to miss that. So guys, thanks very much for joining. As indicated, my name is Desmond, and I'm out.